Let's begin. Today's January 6th, 2025, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria cards 4, 8, 11, 17, and 21. And the puzzle uses the green verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D and criteria card E. Criteria card A takes a look at our middle digit, the square digit, and the Turing machine compares it to the number 4. So should the value of square be less than 4? Should it be equal to 4? Or should the value of square be greater than 4? Criteria card B will take a look at the 3-digit solution, and the Turing machine will let us know how many 1s there are. Are there no 1s? Is there a single 1? Perhaps 2? Maybe even all 3 are 1. Criteria card C will take a look at our first 2 digits, triangle and square, and compare them. So should the value of triangle be less than square? Should they be equal? Or should the value of triangle be greater than square? Criteria card D again takes a look at our 3-digit solution, except this time it'll let us know how many evens there are. Are there no evens? Is there a single even? Perhaps 2, maybe even all 3 are even. And finally, criteria card E again takes a look at our 3-digit solution, but this time the Turing machine will let us know something about the structure of the solution. Specifically, it can inform us that there is a pair, as in the example 131, or alternatively, there are no pairs, but there are 2 cases. One where all the digits are distinct, as in the example 134, or all the digits are the same, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all the 5 criteria cards we just described. And we're going to start off with an initial proposal of 314. So looking out at the list of criteria cards, I'm thinking let's go ahead and test criteria card E. Okay, so the Turing machine does not approve of my proposal. Notice that 314 has no pairs. But since the Turing machine does not agree with that, it's actually informing us that there should be a pair in our solution. So let's go ahead and type that up in our notes in section E. And we'll state that the solution has a pair. Okay. Well, it's interesting that we do have criteria card D, letting us know how many evens there are. But let's talk about criteria card B and D. I always find it interesting when you have this criteria card comparing evens to the number of, say, 1, since 1 is an odd. So I think it's safe to say that you can't have 3 even digits, because if there were 3 evens, then you know you definitely would have 0 1s. And similarly, if you knew you had 3 1s, you'd know you'd have 0 evens. So I think for that fact, we can definitely say that you can neither have 3 evens nor 3 1s. Okay. So that still leaves either 0, 1, or 2 evens. Let's see. Well, let's go ahead and test criteria card D. Okay, so it does not approve of a single even. So that means that either there are 0 evens or 2 evens, since we already established that previously that you can't have 3, and the Turing machine just informed us that 1 is, incorrect. So let's type up in our notes that we'll that the solution has no, I'll say it as two or no evens. So yes, I didn't like the fact of a single even, so there's either two or no evens. So that means we're looking either at a pair of evens and an odd, or an all-odd solution where you do have a pair. Let's see, what else? Well, let's go ahead and test criteria card C. Okay, so again, it does not approve of my choice. So notice that in my proposal, my 3 in triangle is larger than my 1 in square. So, but since the Turing machine does not approve that, it's not the case that triangle should be greater than square. So it must be the other two options. And that is that triangles should either be less than square or they should be equal. So let's go ahead and type that up in our notes in section C, and we'll say that triangle is either less than or equal to square. And because of the equal, unfortunately, I don't think we can actually cross anything out. Yeah, because triangle and square could be equal. Yeah, we can't cross anything out, I don't think. Okay, well, that does it for this round. We have concluded our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice that we did not test criteria card A, comparing our square digit to 4. And we also did not test how many ones there might be. So I'm a little I don't know how to describe it, but I'm a little disappointed. Maybe I should have tested criteria card A in conjunction with criteria card C, since they both have square. And notice also, among the 5 criteria cards, circle is not mentioned. So somehow that circle digit will have to be forced. Now, since there's, other than, the pair, maybe there might be a 1, there might be 2 evens, it's hard to pinpoint what that could be. So if in fact the first 2 digits are equal, it could be that square might be a 4, forcing, and if they are equal, forcing triangle to be 4, and that would leave you with possibly a 1 digit, because if there are no 1s, then you'd have too many to pick from. So it could be that it could be 441 if there are 2 evens. Now, if there are 2 evens, you could also have a pair of 2s, and then again a 1. So I'm thinking either 441 or 221, depending. Now, if there are no evens, that'll be interesting. Then you'd have an all odd with a pair. And yeah, there seems to be a lot of possibilities. So let's see. If I were to choose 441, let's see. Well, actually, I think I'm going to sort of hedge my bets. I know it's going to sound weird. I'm going to come up with a proposal that I'm almost hoping to fail in some sense. And I'm going to pick 221. The reason for that is, when looking at criteria card A, obviously there are three square values that fall under square being less than 4, and that's 1, 2, 3. So I'm almost hoping to eliminate them in some sense, because equal to 4 is just so specific that maybe I'm hoping that if it does turn out to be incorrect, the 221, that I'd be almost able to deduce what that might be and not have to test it a second time. So I know it's kind of odd, but I'm going with 221, and let's see where that takes us. So just to make sure, so here I'm proposing that triangle and square are equal. I'm proposing that you do have two evens, and that, and of course there is a pair. So let's go ahead and test 221, and let's try criteria card A, since that's really kind of the reason I chose that proposal. Okay, wow, look at that. So it is true that square, again, I picked a 2 for square. 2 is less than a 4, so that is correct. So let's go ahead and type it up in our notes, and we'll say that, yeah, square should be less than 4. So square is less than 4. Now, obviously, we're not out of the woods, right? I mean, we still do have 3 possibilities, 1, 2, and 3. So, it's somewhat of good fortune, but yeah, you still don't know for sure. And yeah, I think I'm almost going to have to retest. Let's see. Yeah, we don't know what's paired up. So I'm almost wondering, oh man, going into a third round possibly. There's just too many possibilities. So let's see. Yeah, I think it's almost... Let's go ahead and test criteria card D again. Okay, so it does not like the fact that I have 2 evens. So what does that mean? Well, that means that there are in fact 0 evens. So let's go ahead and cross out the 2 in our notes. And let's go ahead and cross out, yeah, since there are no, again, we established there can't be 3, it didn't like 1, it doesn't like 2. So that means that there are no evens. So let's go ahead and cross out all the evens in each of the 3 digits. So we are looking at an all odd. We do have a pair. And so the question is triangle going to be paired up with square or not? So let's see. Yeah, let's go ahead and test criteria card C. Okay, so it does like the fact, notice that my triangle and my square are equal. The Turing Machine does approve of that. So let's go ahead and cross out the less than, and in fact they are equal. Okay, so what does that mean? Well, we have either 1, 1, 3, 3. So I think it's safe to say we can cross out the 5 in triangle since it cannot be paired up with square. And so the question is, do we have 2 1s or a single 1? So let's see. Yeah, let me, just for my own sake, let me go ahead and type it up. So we know that we can't have 3 ones. We already established that earlier. So it could be 1, 1, but I don't think it could be 113 or 115, because how would you tell them apart? So I don't think you're going to have a pair of ones. Now you could still have 0 ones, but so 113 and 115, I would describe them as being ambiguous. I can't tell them apart. So I don't think you're going to have a pair of ones. Now, you could have, let's see, what if you only had a single 1? Then it would be 133. And if you had a single 1, well, that's the only possibility for triangle 1. You could also have square be 1, and so that would be 313. Could you have, oh, yeah, no, these would not be valid because the first 2 are not equal. Yeah, so it couldn't be 1, 1. It would have to be 3, 3. Yeah, so we are dealing, I apologize, I'm not sure. I'll be honest with you, sometimes it's hard to keep track of everything. So yeah, so I don't think you could have a pair of 1s. It must be a pair of 3s. And so the question is it 331 or 335? So there's where how many 1s really come into play. So we are going to say, though, we're going to deduce that it must be the 3 in triangle. So let's go ahead and cross out the 1s. And so the question, and I don't think you're going to have 3 3s. Let's see. Yeah, you couldn't have 3 3s because that would mean that would be a no pair scenario. So yeah, you can't have circle be 3. So yeah, it's either going to be a 1 or a 5 in circle. And yeah, we're just going to have to do a quick third round proposal. And I'm going to say 331. And let's see. So, yeah, so 331. And so let's go ahead and test B. And no, it does not like the fact that there is a single 1. So here we're going to type up that we're going to deduce the solution has no 1 digit. So it does look like our solution is 335. And so let's go ahead and cross out the 1 in circle. And let's type up 335. And let's go ahead and cross out the 331 down here. And let's go verify. So 335. Fantastic. Well, how did we do versus the Turing machine? Well, it is a 5-card criteria card puzzle, and we did 7 tests over 3 rounds. I'm not sure. I'm hoping for a tie, and then of course the win. But let's go ahead. Let's see. In the first round, we did C, D, E, all wrong. and then we did ACD in the second, and then finally we tested B in the last round. So CDE wrong, and then ACD. Hopefully I'll keep that in mind. So CDE all incorrect, and then I believe it was ACD, and D was incorrect twice, and then in the third round B was incorrect. Wow, yes, we tied. Wow, that was a close call. Yeah, so with 5 criteria cards, doing 7 tests, we just got it right. So, not sure if we could have improved. I'm sure there is. Nothing really comes to mind. Like I mentioned at one point, I sort of wished I would have tested criteria card A in the first round. And, based on what we now know, yeah, I would have gotten a check mark. So that would have been, pretty good. But I don't know how much that would have affected the win. Would we have done it quicker? Unsure. But in any case, how did you solve it? And did you notice anything interesting in your choices in criteria cards or proposals that you'd like to share? Add those thoughts to the comments. If you liked the video, please give it a thumbs up. And don't forget to hit subscribe to not miss out on any future videos. Well, until next time, have a great one.